Good evening and welcome to the Fire Sprinkler CAD Basics Bootcamp. This is week 7, an overview of the post-calc checklist. I'm your host, Colby Stachwick. Last week, we completed our review of our hydraulic calculation report. Now we have everything that we need to complete our document package for submittal to the local authority having jurisdiction. So let's get started reviewing the mCAD post-calc checklist. All right. So behind the scenes tonight, we have our usual crew, my beautiful wife, Monica, my man, Chris Carrasco, who is having some internet issues this evening, but he'll be helping out as much as he can. And my man across the pond, Martin Carl, is helping with the recording tonight. And again, just so everybody knows, they are at the right place. This is the Fire Sprinkler CAD Basics Bootcamp. So we are basically wrapping up, for the most part, our project tonight, showing you the final processes of producing this CAD document for our plan for submittal. This is where we are at. It's hard to believe. We've already come, this is the 7th week of our process here, but we, talked about our different checklists, a lot of information. If you're new to CAD, this is really could feel like you in the image here, right? Like just drinking a lot of information through a fire hose. It could be a little bit much, but where you are, if to be caught up, to be at this point in the process, have you updated your plan with the required GPM and PSI from the hydraulic calculations that we looked at last week? It's really not much, so all we had to do is double click on some text and edit it. Hopefully that gave you, if you were behind, some time to get caught up. And if not, if you're still struggling, your success is our success. Please contact us and let us know how we can help you. A lot of times we might be just stuck on some small issue that can be big for us if we don't know what we don't know. But the solution can be easy and then be enlightening, and then you go through to the next level. If we have any interest in learning 3D CAD basics, we're doing a workshop on Saturdays with Chris Jansen in SketchUp. There's a free version of SketchUp that I really recommend everybody try out. It's lots of fun. It's just one of the easiest to learn 3D modelers out there. It kind of reminds me of old school Microsoft Paint, but advanced to 3D. It's just very intuitively simple to use and a lot of fun. And we use it to make our riser details. You can, make really advanced 3D models with it as well. You do have to have a paid version to be able to import and export back and forth between our IntelliCAD program that we use, or AutoCAD, whatever. But you can start learning with the free version, and it's a lot of fun. To get to the community where we are holding these events, you go to your library and scroll down, same place. It should be right next or near to your boot camp. The order of these things can kind of shift and rotate as, I think it puts the one you were in the most recently at the top, possibly. But you click on that to go to the community, and also in the same area, if you click on your, CAD Basics Bootcamp, that's where you will have access to all of the other course material that isn't in the live lectures. There's other videos to help you, and all of the downloadable content, all of the PDFs with the main core commands that we are using, so you don't have to waste time learning other commands. It's just all right there. All of this stuff is available for you in the Kajabi under this Fire Sprinkler CAD Basics Bootcamp. If any of you are having trouble maneuvering and finding anything, please let us know. We are new to this process as well, and understanding how to best organize things so you can find them. And so, your success is our success. You help us to help you find it, and then we realize, we should label this more clearly. So again, you are here at the Zoom meeting on Thursdays nights for this iteration. We will be followed immediately by a question and answer session for all of you who are here live. And also want to mention in the storefront, mCAD storefront, in the Kajabi, you can scroll down to the consulting section. And during this live session, anyone in here can sign up with a one-on-one session with me for free if you need help. And if you're even struggling to figure out where this is, just shoot me or Monica a message and we'll make it happen for you. We want to help you get through this. Again, I want to remind everybody, 7 weeks. Is your back sore yet? Or is your wrist hurting from being in the same position, repetitive motion? Have you found a comfortable position to prevent that from happening? Cannot recommend enough a scroll wheel. I have seen some of our students. Well, one I can think of specifically this season using what is it called? I forgot it now. Not a mouse, but a scroll wheel, I guess it's called. Anyway, I'm curious as to how you like that. Monica's father also loves to draft. He was a drafter at Boeing he's a modeler in CATIA, and he also liked the trackball. That's what I was trying to think of. Anyway, whatever works for you to keep comfortable is the important thing. All right, so we've been talking about all these checklists. So far we went through the layout checklist, the pre-calc checklist. We had some red lines in between. Now we're coming up to the post-check calculus, but we started with this job order report. We had our information and our layout checklist that got us started with having a piece of paper we could pass back and forth. Here we see it. And then we moved on to the pre-calc checklist. And the idea of this one is just getting enough info so we could get those calculations done. We could get it to the tech who needs to do those calcs for us so that we can complete our drawing. And then, we're working through the drawing. We got several iterations saved in here showing how we could go back and look through this process if we need to investigate if we missed things in the red line process. So, pre-calc checklist, post-calc checklist, that implies there were calcs in between, and that's what we looked at last week. That gave us the information to go into this box on our page. As the CAD technician, this is what we were responsible for with the hydraulic calculation, is just to double-click on this text and change it to say the numbers that match our calculation. The demand at source comes right off the cover page from this graph, which is the 26.5 GPM at 19.94 PSI. Sometimes the source is not always the base of the riser. And in the fire sprinkler world, everyone always wants to know the pressure required at the base of the riser. And that's because it's posted on the riser itself, and when they do testing every year, they make sure that it's still available. And so to get that, we use the same GPM that we had before, but now we use this PSI. This calc program labels it as the finished floor node, and it's telling you that it's node 1, that this is the pressure at. It's, the base of the riser is always at the finished floor. It's basically... It's common in fire sprinklers that whatever the underground piping is coming in, it transitions just above the floor, and that's where we're noting this pressure at. It transitions to a different type of pipe as it enters the building. Anyway, so the gist of it is, you as a CAD technician, you just double-clicked and changed this text, and that's all you were responsible for this last week. So now we've completed the hydraulic calculations. What is this post-calc checklist that we're looking at this week? Well, we have 3 post-calc checklists internally as a company. We have one for 13D, one for 13R, and one for 13. This project that we are working on for this course, this introductory fire sprinkler CAD course, we are working on a 13D project, and so that's the post-calc checklist that we are using. This is going to start out, let me see if we can zoom in a little bit here on, we'll go ahead and look at this technician's note. Better not go out of place in my slides. Up at the top, it says, this is quote right from NFPA 2019 NFPA 13D. It's 4.4. And at that section, it says documentation. Documentation shall be provided upon request to demonstrate that the water supply, listed devices, and sprinkler coverage comply with the requirements of this standard. And then in the annex under 4.4, it tells you that a scale drawing, where required, should show the following. And our checklist here, the first few items that are all in black are straight out of NFPA 13D 4.4 or Annex 4.4, that list what they want. And then the blue is like our explanatory information to help our technicians understand, what this is talking about. And then after, actually, the majority of this checklist is additional things in blue that we have just found commonly that jurisdictions want to see. And so we just put it on there because it's usually, fairly easy to give them. Or maybe not necessarily just that the jurisdiction wants to see. Some of these things are beneficial to make it easier for the technician as well. Anyway, you will see as we go through these. But first I want to talk about, you notice here, this is the 2019 edition that's quoted on the top of there. That's what's current in Oregon, and that's why I have that on there. This next slide is showing in the 2016 edition. It says the same thing, but it's 4.5 rather than 4.4. The reason that I have this is because I want to show you what the handbook from 2016, NFPA 13D, has to say about this paragraph. And there isn't a handbook for the 2019 as of yet, or I would put this up there for it. But it's talking about the same paragraph. It's just in a slightly different location in 2016. But this is what the handbook has to say about it. It says, NFPA 13D has not and still does not explicitly mandate the production of formal plans, specifications, and calculations, as is the case with NFPA 13 and 13R systems. And like that whole sentence would blow a whole lot of plans examiners' minds just hearing that. And this is written by the NFPA committee as explanatory material to help people understand the NFPA codes, the handbooks, but not everybody looks at these. Anyway, it continues. However, the intent of this paragraph is that authorities having jurisdiction can request such documentation. And when they do, it must be provided. This paragraph was revised for the 2016 edition to better clarify this intent. The reason the NFPA 13D does not mandate sprinkler system documentation is that systems installed in accordance with NFPA 13D should be less complex than those of other standards. A designer and installer who are sufficiently knowledgeable with the provisions of NFPA 13D are expected to be able to correctly convey the basis of the design and installation from the approval process through to construction without such documentation. However, many authorities having jurisdiction find the concept of having sprinkler systems designed and installed without a plan review difficult to manage, to say the least. To address these conditions, this paragraph and its accompanying annex text identifies the basic system information that should be provided. It is also the intent of this paragraph and the associated annex text to allow sufficient flexibility in the approval process to incorporate changes consistent with the rules of NFPA 13D on the job site without the need to resubmit documentation for additional approvals. And you would be surprised how many jurisdictions don't see it that way. Anyway, also it is expected that the simplified calculation technique included in NFPA 13D would be allowed by the approval process. And I would say that that is being accepted more, but I think there's still places that probably won't accept it. Some of the stuff, I mean, there's crazy stuff that some jurisdictions want just because they're used to seeing it on a 13 job, because 13 does require it. and they just can't handle the fact that we're not required to do it in here. And the total intent of that is to keep the cost down, and that's a little too much for them to wrap their mind around, I guess. Anyway, moving on. So the first thing on our list, which seems like a pretty logical one, the address. So on our plans, we zoom in. This was our sample ranch home. That's where that goes. We're just kind of moving through the checklist, checking things. And a lot of these things are already things that we have done previously, right? We are just really literally dotting our I's, crossing the T's, and making sure that these things have been done correctly. Maybe they were done, some of them may have only been done enough for the calculations to be completed, but not necessarily completed to the full amount that they needed to be. So now we're kind of tidying up those things. Anyway, so the next thing on the list is the size. I gotta read the sentence before I move on, Colby. So the size and type of domestic line, including the link to the city connection. Now, our project that we worked on was a tank and pump, and so this is not applicable. But in the course material, it wasn't in the live lecture, but if you go into the course material, we did have a video of working on hydraulic calculations with our project if it was in a neighborhood connected to public water supply. And so this is basically what that could look like depending on the situation. So we're showing, this instance, we're saying it's an existing 1-inch PVC line up to this existing 3/4-inch meter. And then from the meter to the street, it's an existing 3/4-inch copper line. And that's a pretty common arrangement, I would say, in the Northwest. That's probably why, I did it like that. I'm just kind of trying to make something to demonstrate what's possible. All right, so next one on our list is water meter size. And again, we have in blue just to help explain, if it's a well, this might not be applicable. And again, just the same picture again, it's right there is the meter. We have a symbol for the meter, and then we have it labeled. And the next thing is current static water pressure. Now, that is all, like we had some conversations about this the last couple of weeks. That's really all that's required in 13D. A lot of jurisdictions end up still wanting full water flow data. And so we have this set up for houses on water flow. So we would put the results from the water flow tests that the water jurisdiction gave us. We would calc based off of those, but we have this kind of disclaimer here that a lot of times the houses that we're doing have existing water lines, and they're existing houses that are getting sprinkler systems because things like they're taking a house and turning it into a daycare, or they're taking a house and putting it into an adult foster care home. And so it's an old house. It already has a water line. They tell us the info about it. We calc it. It works based off of what they told us. But a lot of times it doesn't match up. Either there's a change in pipe size that nobody knows about that's buried somewhere, or there's just so many things that could happen. It loops around the house for some reason that nobody realized, or just weird things. The pipe could just be corroded because it's galvanized pipe, and so now it was 1-inch galvanized, but it's the equivalent of like 1/2 inch on the inside, so it just doesn't flow the way it calcs out because of the restriction in there. So basically, before it gets finalized, they will do a flow test and make sure that there is enough pressure. And if it doesn't work, they will have to switch to a tank and pump. That's what this disclaimer is here at the bottom. This is the one that we have an alternative version if they don't have a typical water supply off of with a static residual pressure and flow like we talked about in the calculations last week. So this is like what we had on our project with the tank and pump. We also have, another we have several versions of this that we have in-house that are just slightly different. But we only talked about these two in the course to not over complicate things. But that's basically what we use, whether it's if it's on a well, or what did I have there? A tank or a pump or a well. Tank and pump or a well, I should say. Okay, now number 5 here is interior walls. This is like a crazy thing. I have no idea. This kind of like gives you an idea of like the level of what they're really expecting. It's like we better tell them they have to put the interior walls on there. Like, there's not like a high bar of what they're, trying to get people to provide here. And what we're doing is really above and beyond, and it's really like practicing getting ready for doing more advanced sprinkler systems that really require us to go to the level of detail that we're doing. And a lot of this stuff is basically just so easy to provide because we are used to providing it on those systems. It's like, okay, why not? Anyway, so we show the walls. There we go. The walls are there. Now, next one, model, manufacturer, temperature, orifice size, and spacing requirements of sprinklers. And then in blue, it says all of this should be in the head legend. Okay, we have the information on our job order report telling us what sprinklers are being used. And that's how we know. Here's it zoomed in just so you guys can see it. We were using Senju concealed 4.9 sprinklers. And this box is the head legend at the bottom of our plans where we put all of that information. You also can find this information on the sprinkler head cut sheet. This is, the sprinkler 4.9K factor. And then in the back, we are talking about, here we have the 16 by 16 spacing that we're calculating to. There we go. Got a little better view. So all of that stuff is, places that we can find that information for trying to fill out number 6. Number 7, type of pipe. Now, most of the fire sprinkler guys that we are working with are installing CPVC fire sprinkler systems. This is orange PVC pipe. You may have seen white PVC at the hardware store. It's compatible with that. If this plumber brings in, PVC underground and we connect to it, we can just glue straight to it. It's the same size and everything. The orange of our pipe is it's a chlorination process that makes the pipe withstand a higher temperature so that it's, if there is a fire, it's not going to melt as fast. And it's not the same as like the CPVC pipe that's kind of a yellow that they sell at Home Depot. That stuff is total garbage. Stay away from that. But this stuff is actually, interestingly enough, I guess, side note, maybe it's interesting to people, maybe not. The orange CPVC for fire sprinklers is a little bit, it stands up a little bit better than white. And one of the ski resorts, when I was working for a sprinkler contractor near Mount Hood in Oregon here, one of the ski resorts on Mount Hood contacted us about buying some orange sprinkler CPVC pipe and tees for making rope. I don't know what cues or whatever they do for the ski lines, because it held up better in the sunlight than the regular white PVC when they used that. So that's kind of an interesting side note. Anyway, totally useless. Sorry, guys. I can't help it. But where we find this information on our plans, type of pipe, is in the general notes box. It says all materials are CPVC pipe and fittings unless noted otherwise. We do occasionally do plans for plumbers in PEX, and we just change the note. Okay, and I guess occasionally we will do one in even copper or steel. It's pretty unusual, but I have done those before. It's usually because the pipe is going to be exposed and they want a sturdier pipe. It's legal to have the CPVC plastic pipe exposed now. It didn't used to be, but it's not very pretty. So some people, if they have to have it exposed, like to have either steel or copper because it's pretty, but it's more expensive that way. Anyway, hanger spacing requirements per the manufacturer. Again, this is off of that list in the back of the annex of 13D. So they want this hanger spacing table on here that we have it in the bottom corner of our template. And that's, when we were talking about how the hanger ticks and how like 13D doesn't require that. I don't usually put that on a lot of 13D jobs, but when I'm teaching new guys, I have them put them on just to get used to putting hanger ticks, just adding it to, thinking about their process. So when we get into 13 systems, it's easier to explain what's going on with them. Okay, so the next thing is riser detail. So on our project that we did, we used this home hydrant, and this is our riser detail. This pipe that's in the center of that tank on the drawing there is our riser assembly. And pretty much all our other jobs, 90% of them 13Ds, this is the other riser detail that we use. Basically either that tank and pump, or this. If we are connected to at the street to a municipal system, this is the riser we would have. If we're connected to a well system, it would be the same as this as well. So installing contractor information, that's pretty straightforward. This is where we have that on the drawing. And preliminary hydraulic calculations, again, that's just talking about these numbers. This is preliminary. We have to actually test it once it's installed to make sure that it works. And that's the numbers we got last week and put them right here. And okay, you can see we're done with all of the black items. So everything from here on out on the list is just stuff that we have come to find. We better just put this the same way that we do basically for the most part on 13 systems, because they're just used to seeing that. So let's just do it. So sprinkler quantity, this is, no big deal. Let's do that, right? We just put the number of sprinklers in our legend. How many are there? We count them up. No big deal. So we also, this is a thing that we started doing just to make it clear to plans examiners. We've measured this. This is the square footage. In the past, if we just didn't put a sprinkler in, and they may have a question, why didn't you put a sprinkler in the bathroom? It looks like it could be maybe because they're familiar with it, but they think it's too big. Or maybe they're not even familiar with this rule. But if we just have it marked on there, hey, this is the rule in the code book if you want to check, and this is the square footage that we measured of this closet, of this bathroom. Just to basically head off any trouble at the pass. This is what that would look like in your project. This is all the places that we labeled out those spaces on, kind of zoomed in here. And here's the other side of the building. Now, next thing on our list, let me see, where are we at here? On time, and okay, good. We're looking pretty good. Next thing, design pipe and dimension pipe. And that was basically that was our pre-calc checklist. The first thing we did, we laid out our sprinkler heads and we connected the dots, right? And then at the end of that week, the last step that we did, I guess that was 2 weeks. That's right. First week, we laid out the heads and connected the dots. The second week, I don't remember everything, but the last thing I know was dimensioning the pipe. Anyway, and so after the end of the pre-calc checklist, we ended up with this. And that's how we were able to, that gave us enough information to produce our hydraulic calculations. Okay, now something that we didn't really deal with, but if you are taking this course and you work, maybe you are a contractor and you have a logo, or you work with contractors and you want to put their logo in it. This is kind of an example. This is what our template actually looks like in-house. It's a little bit different than the one that you guys got. You can see it has our logo on there in a couple places. It also has, the client's logo right there. And so we just, have as a double check on our list, make sure all of those are showing up like they're supposed to, and they're appearing in color on the print. That is, in fact, the only thing that appears in color on our print, and that is Our prints are designed so they will still look good if they make the copy in black and white. Doesn't make a difference in how the print is readable. Only thing that changes is the logos will be in black and white. Okay, now this is optional. I was mentioning earlier, I really don't, this is not necessary at all on 13D systems. And, it's up to you if you want to do it. We're just talking about putting the little hanger ticks, showing them on the piping. And we do that a lot of times. It's very necessary on 13 systems because we have to, a lot of times we're being very specific about like what we're hanging to. And, it's just more detailed. And so, really, again, I want to iterate that the only reason I have my guys on houses do those hanger ticks is just to get used to the concept of, how this works of putting them on there. And okay, here's a pic of what I'm talking about. These little tick marks are the hanger symbols. All right, so we made it to the back side of our list here. Verify correct job number, date, and technician initials. So this is on the bottom lower right-hand corner of our plan. We look in here, we got our job number. It's the YouTube 2022-001. First house I drew for YouTube in 2022. We got my initials, we got the date. All right, we got next, placed underground note on site plan. Okay, and now, again, we, in the, word salad there, let me regather myself. In our practice project that we worked on, we had a tank and pump. So there was no underground piping, and so we don't have a note about that. But again, in our video about calculations that you can go back and watch, when we did a calculation of a system connected to a municipality, in that situation, we did have a site plan. And this is what it looks like. It's, it says this site plan is for reference only. Usually the sprinkler contractor has nothing to do with the underground piping. We're just referencing it for the hydraulic calculation. So you can see like, yeah, that's the correct amount of piping that we put in there in the calc. But it's put in by someone else. So it's why it says this is for reference only. See project drawings for additional site plan information. Underground piping by others, by your sprinkler contractor to start work from the discharge side of the double check valve. All underground main per Oregon Plumbing Code and NFPA 13D. And, we'd alter that slightly depending on where we are at. Okay, so the next thing we have on here is verify north arrow direction. And again, we didn't really worry about that too much with our tank and pump situation. It's like a made up location. It's just a house I drew. And so, which way is north? I don't know. It was pointing up. That's fine. But if you really have a site where you're placing the plan, traditionally the site plan is always drawn with the house facing north. And so on the left, we have a site plan. You can see the north arrows pointing up. And on our actual plan, it's typical to put the front door at the bottom of the plans, also in architectural plans. And so when we flip the house around to do that, now the north arrow is rotated around. And so that's, this is correct layout for this site for the north arrow. But these are the types of things that we were talking about here. All right. And again, kind of seems like a minute detail, but this is some jurisdictions really want this. So we just go ahead and give it to everybody as long as it's easy to obtain. Okay, installation tenting detail. This is the detail you may have seen on your plans that that's talking about. We have some jurisdictions that have, they want us to word. We have a separate detail. It looks exactly the same. but slightly different wording that they want. You know, every time we work in that jurisdiction, we have to give them that detail or they reject the plans. Nothing different other than like 3 or 4 words. But what this is talking about is keeping the insulation above the pipe so that the heat from below in the room is keeping the pipe thawed. This is just, you know, some of you guys are in places where they don't really care about this too much, where it doesn't freeze, but we have to worry about it in Oregon. This is there's a couple pictures, details in the 13D code book showing of different options for doing it. This is with bat insulation shown here, an option, and then but typically with blown in insulation, this is how they would do it most projects these days. Let's see. So specify minimum distances from heat sources per table 7.5.6.3. Okay, so again, this is kind of like the closets and the bathrooms where it's not required. Pardon me. It's not required to mark out specifically, call out what section these are from. But by doing so, we found that it just relieves a lot of problems with plans examiners, especially when we're moving into new jurisdictions that we haven't dealt with before, you know, that are not familiar with our capabilities, I guess. So this is, I think I have a zoomed in one. Yeah, our note that we had about the oven, you know, just keeping 18 inches away from there. And this is really to help the fitter in the field just remember, oh yeah, I can't, you know, got to make sure I stay a little bit away from the oven. Sometimes it'll be a, you know, gas fireplace in the living room, something like that. You got to be even further away. Just have to be conscious of it. You usually can work around them. All right, so if providing a cross section, again, because it is not required by 13D, but if you are providing a cross section, and we just always do if we are given one from the architect or home designer, whoever did the drawings, sometimes home plans can be really primitive, like literally almost a napkin sketch, and there aren't always cross sections. But if we have one, we put it on there and we put a dimension from the finished floor to the center of the first floor sprinkler piping. Now, we haven't talked about any of that yet. So this is our first video of the night. And so we're going to show you how we work through putting the piping into the cross section accurately. And like, again, this isn't required, but this is an excellent practice because it is required, this exact process, when we are doing a 13 job. They do want to see these elevations, and it's mainly for the plans examiner to see the elevations for the hydraulic calculations, because in the hydraulic calculations, the biggest pressure losses come from elevation. Okay. So here we go, guys. I'll see you guys on the other side of this video. All right, we need to do a little bit of work with our cross section here. Now 13D does not require cross section, but if we have one, we provide it. Some plans examiners can't wrap their heads around the idea. We've actually been required to have one when none was provided by the architect, and we had to create one ourselves. And that's really unusual, and the sprinkler contractor should not be required to create a cross section. That's for a 13D system for a house. That's beyond the scope of their abilities normally. And what I'm about to show you to modify this is also, I would expect, beyond the abilities of most sprinkler designers that are just working for a sprinkler contractor, maybe just have learned sprinkler design software, not really familiar with drafting. But you know, as you'll see, it's not super complicated. The issue that we have that we're going to be addressing, if we look at this section right here, where if we were to slice this like a cake, drop this part away, and then this arrow is the direction we are looking into the building, which is what this represents here. on the right. You know, there's nothing going on right in front of here as far as piping. There's this one pipe right here, and directly, you know, where this is happening, that's it. You know, there's this stuff happening beyond. But if this cross section was just a little bit further back, if we just, you know, I don't know what this is, but a couple more feet back here, we would be looking right at all of this piping. And that's a lot more interesting, a lot more helpful information to add to our section if we want to, you know, have it represent useful information for someone, the person installing it or the person reviewing it, whoever. So if we look at where this is cut, if we just move to this line, you know, there's differences in walls. If we look here, it's kind of going through the middle of this wall, and then there's this wall in front of it and this wall. Whereas over here, if we move the section back here, there's only the one wall here. In fact, let me just draw a line real quick to represent where I'm talking about. We're just going to say we'll move it to right there. So if we compare the 2 points, you know, there's a wall here and a wall here, but down here, there's only a wall here and no wall here. So that's a modification we'll have to make to that section. We get to this wall, that one's the same, no big deal. This wall is the same, no big deal. Same thing here. Now we get to this hallway, and we have no wall right here where there is one here. And then we have a wall here where there was none here. And the other thing is that we would be able to, we're going to be looking and we're going to be able to see these sprinklers, and we would also see the corner of the wall, which would look different from if we were slicing through the wall. So let's kind of let's go start attacking this, and let's just see how we would do that. So I'm going to grab the pieces of this, and I'm going to move that, and I'm just going to use this new line I made. And so now how can we make this represent that? Let's just start on one end. So the first wall that we encounter is like this double wall inside the wall of the closet situation, and we're going to end up with going through just wall and then seeing the corner of this wall. So that's this situation. And basically, all we really need to do is just, you would just see the single edge, the outline of that wall. So if we just get rid of all the framing for this wall, and basically all of this ceiling line would be contiguous. So I'll just reconnect it. All these would just continue. And so that area looks more accurate now. We're slicing through that first wall, and we just see the edge of that corner where the next wall is. If we wanted to get really accurate, you know, we could put the door in there as well, but, you know, we'll notice it wasn't in there already, so we're not going to bother with it. It would have been seen from there. But this section was done with a I forget what the name of it is, but there's different ways to represent a section. You can, like, we generally show it so there's it would be back clipped, so you're only looking and seeing like either exactly where the line is, we're seeing what's going on right where this crosses. Like if we were going to show only where this line crossed, we would show that pipe crossing it and that pipe crossing it, and that's nothing else. But so what we would like to show is all of this piping, because that's a lot of good information. So if we imagine, let me just draw a line, or I'm just going to copy this one. We're basically going to be we're modifying this new section as if we were standing, or we could even just use the old line, I guess, that was there where the section was. So now we're modifying it so we're standing at this line and we're looking forward and we see as far as this line and we don't see anything past that. That's what we're trying to make this represent. And ultimately we're going to add the piping as well. And I know I'm already taking too long, so I'm going to kind of try and move through this a little quicker now. Let me see. The next thing, see, we dealt with this wall and this wall. This one's the same. This one's the same. This one's the same. Now this, we would have the situation where there's a wall here that wasn't there before. And then this one that we were going through is just going to be a corner that we see, like the one we just modified. So let's go to that. That single wall, this is the last room that's shown on that section. And so we were going to need a wall here. Let's measure. Let's go this framing. Oops, let's change this from mCAD sprinkler to mCAD standard. So it's 3 foot exactly, this wall to this wall. So when we come over here, what I will do is I will start by selecting all of this and copying it over 36 inches, which is 3 feet. And so now I can just use the trim command and select that edge and trim that sheetrock out of there, which no one would even be able to notice that if we didn't do that. But, you know, showing you how to be thorough. Most engineers don't care about the fact that you wouldn't see it. Let's see. Should have done it to the sheetrock. Oops. There we go. All right, so that wall is in. That's this wall here. And now we just need to modify this so all we see is the edge of the corner from where we're standing. So that's this wall here. We want to remove everything but this outside sheetrock line. I guess we can get rid of those too. And same thing down here. And that's odd. There's different flooring here to here. But no one will notice. All right, so that's the corner that you would see from there. Now, we can get rid of this. We're not, we'll just, let's see, how do we want to do this? We'll just move it to the side. In fact, we'll take this with it. I don't know, just in case we want that information for some reason later. Now, just get that out of our way. This is helpful because this is showing us the elevation of the pipe. Let's go over here. Let's start. This first pipe is... Here, let me switch to mCAD standard dimensions. This pipe is 3'2" off of that wall. That's this wall right here, the sheetrock. So I'm just going to draw a construction line up wild at 90 degrees. And I think I said 36 inches. I just moved that over 36. Is that right? No, 38 inches, 3'2". So let me just select that and move it another 2 inches. Now, this pipe is at the right position, but it needs to be right there. So that is the first pipe in our cross section that we have shown accurately. That is where the section is cutting through this pipe right there. All right, so now we remember we're standing here at this line looking this direction. So the next thing of interest that we see really is this sprinkler head at 2'7" to the right. So I'm going to come over here to my section, and I'm just going to start by drawing a line. Make sure that ortho is on 2'8". And then I'm going to draw a line perpendicular to the ceiling. Now the way that we show sprinklers in a cross section is over exaggerated, as always. Like on the plan, you know, it's way larger than real life, and we show it as coming down through the ceiling like a pendant would. Again, way larger than real life. But just in this simplified version, we're using a concealed head, so it's not going to come down through the ceiling, but this is just to make it clear. This is how we represent on cross sections where a sprinkler is at in the, you know, in the pendant position. So from the ceiling, I could select that, grab that grip and pull it down another 6 inches. Then I'm going to draw a line right here, a little bit just wild, but I want it to go perpendicular, 0 degrees straight across. And I'm going to type in 6, enter, hit escape. Now I'm going to select this line, grab the grip in the middle, and put it right there. And that's representing a sprinkler. Now I'm going to select all of these. I've been using construction lines, mCAD reference, to draw it. That layer won't print. I just selected them and put them on mCAD pipe by selecting mCAD pipe from the drop-down reference here, from the layer tools that I have up here. Now, one thing that's interesting that we haven't dealt with yet, this is why cross sections are important to use if we have them, because you notice things that you don't notice as easily on plan view. There is a change in ceiling elevation right here. And I noticed it, but I just ignored it until we got to this point in the course on purpose so that we could address it now. So we are going to need to rise up and continue across this direction at this higher elevation. And, you know, there's a few different ways we could figure out how this is going to happen. You know, if we look at our floor plan, it happens to say right on here that this is a 9-foot ceiling and this is a 10-foot ceiling. So we need to put a 1-foot vertical rise right here. And it needs to be tight to this truss right here. So, or to the wall as it's going up here, so that it can be insulated. I don't know if we've talked about tenting or not at this point, but that's basically, tenting is something you have to put like visqueen over the pipe before you put the insulation in, so that the heat from the room as it's traveling up through the ceiling keeps the pipe thawed. There's water in the pipe. We don't want it to freeze. And so by covering it with visqueen before we insulate, ideally the idea is we're keeping any of the insulation from being below the piping, because we want it all above the piping. That way we create a little trapped area that retains the heat, and this pipe never freezes. Okay, but sorry to go into the weeds on that, but we need to, you know, figure out how to just travel up to here. So one thing we could do, we know that this pipe is in the right elevation. This pipe is in the right elevation. relative to this bottom chord of this truss. And this bottom chord of this truss is the same. It has a 2x4 bottom chord. No big deal. We could just use that as a point, copy, copy, and you know, there's no vertical or no pipe passing through the section right here that we would be crossing, but this just gives us our elevation. I can just bring that over. That part's right now. I'm going to get rid of that. We don't need that. But one thing I also use this little circle for, it is a little bit exaggerated. It's not quite accurate, but it makes it easier to see what's going on. This is a little bit larger than a 1-inch pipe. I think it might be 4-inch. Looks like it. If this is a 3.5-inch member, that makes sense. So it's pretty exaggerated. So that being said, when we go up this way, there's going to be an offset hanger that's holding it off of this wall as we go up. And so I just use this circle again to, as it is actually pretty close what this comes out to by using this as a circle like that. This elevation is pretty close to the right height of the offset off of the top of where it sits. I think that might be how I size this, but don't quote me on that. I can't remember at the time. So let's make a copy of this, and I'm going to go by quadrant of this circle. I'm going to snap to nearest, and I'm going to snap to what would be the outside face of this framing going up right here, because that's what we would be going up alongside in the attic, where we would be going vertically with the pipe. But I'm just going to use the center of this to create a line, and now get rid of that circle. Come down with this. Now I can select this. I can pull it to that line, use perpendicular. Now I could do trim. I could select all of these as my cutting edge, and now I can just trim, trim, trim. Now I can go match properties, trim that into a pipe. So now we're traveling up and along the the elevated, the 1 foot change in the trusses that's going on. So now we can figure out, the distance between this pipe and this pipe. We'll just measure. That's 3'2". So now we know that we need to add 3'2" from here, a little vertical piece. And I just use the same symbol. Where are we at? Here we go. I'm going to put it right there. We measured that it was 3'8" from that point, so I'm just going to go over 3'8". Wow, that seems something's off. So, boy, where is it? I'm not really going to... Okay, so I want to demonstrate something with this. Like, something I modified isn't quite right on my section. And there's two things. We could figure out what it is. And that is a skill that is useful in fixing this. But it's also useful is very often we're coming across these sections that there are things that are funky with them. For various reasons that I really don't have time in this video to go into it. The architect may do them not actually in a straight line. It's not uncommon for the section to not be cut in an actual straight line. I can't remember the project. I was just working on one where it was that way. And so what I'm going to show you now is how I'm going to put this in the right position regardless of the fact that those measurements were wrong. Okay, so I hope that makes sense. Just because sometimes there's times when you need to know how to do that. I probably, I'm guessing, if I just had to guess, it's probably something to do with my 38 inches instead of 36 inches. But that's not quite enough to make the difference here. This is that 2x4 wall we were talking about coming up the side of. So what I'm going to do is I'm just going to move this circle from the quadrant on this side. So I guess I got to select the move command. Select the circle, then move. Then it's asking me for base point of displacement. I'm going to select the quadrant, and I'm going to go to perpendicular, and I'm going to touch the wall down here. So this has got me coming up the side of that. So that's pretty close to where we need to be. And we're going to have to modify these dimensions here and trim out this circle. Let's see, let's do that. Let's trim out the circle first. Now, the best way to do this would be so that the pipe, like this is a vertical raise, and so you would show it just trimmed to the center. Like let me display this real quick. What that would mean is like that is the ideal way to show it, but our symbol is a little bit too small and our lines are too thick, and so when we print to paper, what you see here is it just kind of like looks like a filled circle almost. And so by showing it this way, if we had a bigger circle, what that would represent is that shows you that this pipe coming from the right hand side is at the top of this riser nipple, and this pipe going off to the left is coming out of the bottom. You can tell that by the way it's trimmed, because if you were looking, down on this in plan view as we are, that's, what it would look like, if that makes sense. You would see the top pipe going into a 90, and then the bottom pipe, you wouldn't see the fitting. It would just be coming out of the side of the bottom, right? Out of nowhere, seemingly. So that's what this ideally represents when you're representing vertical pipes. Now, I don't bother with this on basically anything other than when we get into 13 systems with pipes larger than 2.5 or larger. We don't bother with trimming them out in this manner. We have to use a larger circle for it to be visible. And it makes sense, in those situations. But for everything else, any pipe 2 inches and smaller, we just use this circle and we just trim it out completely. So I'm going to do trim again. And so in plan view, that's how that would look. And like this hanger should be moved now from this point to this, whoa. There we go, center somehow. I turned on quadrant all the time. Now we need to adjust this dimension. Instead of going from there, it goes to here. And then now we need another dimension. There isn't one in between here. So I'm just going to go from here to here. It's 8 inches, and that's totally wrong type of dimension. But if I go to match properties and touch one of these that are right, and then touch part of it, it fixes it. So that little pipe is 8 inches. And we will also need to label that. And ultimately, we're going to have one on the other side over here. So I think I'm getting long-winded. I'm just going to show you real quick. I'm going to trim that. Let's see, and then we'll fix this dimension. use match properties to fix it. And we're going to need another hanger here. All right, that looks good. So this is good. Now we're going to go over here is where we'll label. Just going to go copy. This is in our tools in this area. This is where you get the circle for the riser nipple symbol as well as the label. Now I'm going to zoom in on here, snap to the same spot. Now it's not going to be 1.5 inches. And it's only 1 foot. 0. And now that that is correct, I can just copy it over. Okay. Now, let's see. We need these heads in here. How can we figure out where are the heads in the living room? Isn't it the living room? Do we call it something else? The great room. Okay, so they're centered in the room, 8 foot from each other. So let's just, there's a million ways we could do it. Let's find the center of the room. I'm going to go from that corner to that corner. There's the center. I'm just going to draw a construction line up wild. I'm going to delete that one. Now I'm going to move this one 48 inches, and I'm going to copy this one 8 feet. Now I could take this, I can go copy, I'm going to go from that point, and I'm going to go to this intersection right here. Alright, now I hit escape. I could select this one, and I can go copy, I pick one of these points, and I can go perpendicular. Okay. Well, you know what? Thinking about it, I'm going to show you another tool. I'm going to go back. This is the center of this room. Some of you haven't seen this before, but I'm going to use, to find where this pipe is over here, I'm just going to use the mirror command. So I'm going to select this vertical pipe. I'm going to grab a chunk of this too. That way we end up with some pipe already started going that direction. So I have those two pipes selected. And here is mirror. You could also type in mirror in your command bar. But now I have those selected, and it's asking me, oh, I forget about my zoom. It's asking me to start the mirror line. So I am going to start, on this point of this line I drew, and I'm going to reflect it about, I have ortho on, so if I just, let me turn off F8 to show you. If I turn off F8, it'll do it anywhere, right? But if I snap to this point, it'll do it perfect. Or if I just turn on ortho and move my cursor up, it'll do it perfect. So I'm going to click there. Now it's asking me, do I want to delete the original entities? And I don't. So I'm just going to hit enter. And there it is. And so I can just, select this pipe, bring it on over to, all the way over to here now. Here we go. And I'm just delete these construction lines now. Get rid of that one too. And so let's carry on. Let's see, our next room here is this little entryway, and it looks like it's 2'10" from that vertical change. So if I copy this from this point to this point and go 2'10", well, that's going to be where that's at. This next room is the laundry room, and I've got a couple things going on. 5 foot O from that head, I have a pipe going that direction. And then in another 2 foot 8, I've got this head. So what I'm going to do, hopefully I did better on this side with drawing my, modifying this section. We'll see if it works out over here. I'm going to try copying this over. 5 foot O, we'll start with. Now there was no sprinkler here. That was where the pipe going the other direction was. So I'm just going to copy this onto that point since I have it right there. And now I can move that over the additional 2 foot 8. I'm just going to pick a random point, keep ortho on, and type in 2 foot 8. So that looks more correct than what we were dealing with before. I'm going to go ahead and copy this circle onto here because we have another pipe over here that is coming towards us towards the garage to feed this tank, and that's 2 foot 6 over from that head. So by placing that on that head, I can now just grab it. What was it, 2 foot 6? I hope that probably wasn't right. Oh, come on. 2 foot 6 is 30. Let me try that. It was 2 foot 6. Okay. So that, now we just have to connect this. So there we go. I mean, that's basically all the piping that needs to be shown on our section, and that's a much more useful representation of what's going on. I should probably trim this out. Again, none of this is required by 13D. They're trying to make it simple. But, you know, they're really trying to make it comparable to like a residential house plumbing drawing. You know, you don't need to lay out the piping on that. You just show where the fixtures are. But in a jurisdiction that wants you to have something like this, this is how you would provide it. And when we get into 13R systems and 13 systems, it's a requirement to have a section. Now, the most important information now is actually not on here yet. What is useful for the plans reviewer is to have the elevation of this piping off of the finished floor usually. Because that's, which when I say finished floor, I really mean this, like not the floor that's got, like whatever your finish is, like wood, but the finished subfloor. All right, what layer do we want that on? Let's go mCAD text. So now we have a useful elevation that will be on our section. Let's go to our, it's taking a second to update here. Here we go. So there we go. We have our updated section with the useful information that we are looking for from mCAD. So now, you know, we can go ahead and print this out, make a PDF of it, and submit it to our manager for review. All right. Thanks, guys. All right. Let's keep going here. So now we talked about here, that was that last checklist item was to dimension to the finished floor to the center of the first floor sprinkler piping. We showed that. This next one says dimension center of piping vertically floor to floor. Well, project that we did, you know, it was a single family, single story ranch home, right? So what does that look like? Well, here's another project. This is a 2-story home, and this is what we're talking about. We're showing the elevation difference between the piping floor to floor. And again, this is helpful to the plans examiner when he's reviewing the hydraulic calculations, because our pressure loss, our biggest pressure loss is that elevation going up from floor to floor. And so, you know, we don't want to put, you know, just throw a higher number in there. We want it to be pretty accurate because, you know, sometimes this, you know, it can be pretty close to making them work depending on the situation. So here we have good evidence for the number that we use in our calculations. So let's see, verify correct sprinkler information in node legend. Okay, so what is different from this, from the sprinkler information we were talking about before, was we have this little node legend to help the plans examiner understand what some of the nodes represent in the hydraulic calculation. We always have 0 representing the water supply, and that is because that's one of the limitations of Sigma for our hydraulic calculation program, is that the source has to always be 0. All of the other numbers can be anything, but they have to be numbers. And so we always represent 0 as the water supply, 1 as the base of the riser. That could, you know, this could change, but this is what we have standard dropped into our, you know, our template. If the underground, it's really not going to usually be on a 13. Well, it could be. Like, for example, that one underground drawing that I showed you earlier that had the 3/4 inch copper coming to the meter. And then, I don't remember, I think it was PVC from there to the house. In order to change from the pipe types of copper to the PVC, I have to add another node in there. And so at that point, 1 would be at that, what was it, the water meter? And then so 2 would be the base of the riser. As long as we don't have to do that, we make 1 the base of the riser, 2 is the top of the riser, and we just start on a single story place at 11 and 12 for the sprinklers. If it's a 2-story, I'm going to do 21 and 22. It's just a way to have it be the same all the time. There's always enough nodes in between 0 and your sprinkler number to account for all the changes that you need to, you know, input into your calc program. And on apartments, on a 3rd story calc, we do 31, 32, 33, and 34 on a 4-head calc for a 13R. So anyway, just ways of keeping the numbers straight, what they represent. So dimension, center of steel pipe, if any, to face of wall in 2 directions, in 2 locations per floor. And the reason that when we have exposed steel pipe, specifically, some people want this even for plastic, just to kind of know where heads need to be placed, but it's more specifically for steel pipe because it's usually prefabricated off-site and brought on-site and then put in place. So you kind of have to know some starting places where to place at least part of it so that it all works out, that it fits. And so, you know, these are the types of dimensions that we would add for those types of things. Here I added, you know, 8 foot max because this head is maxed out off the wall. It's really more of measurement about the head being how far it is off the wall, but this is the type of thing that we're talking about there that we would do. And, you know, you might want, so we've had some guys in the course that like doing this, that said that the plans examiners that they work with like to see this. That's totally reasonable. So total area of sprinkler work and total building area, not always exactly the same. But now we have a short video on a method for measuring it using the polyline command. And this video, I believe, was about 7 minutes. Is that right? Yeah, just under 7 minutes. After we come back from this, I think there's only about 10 more slides, so I'm not going to do a video. We'll just go straight into Q&A from there. So see you on the other side of 7 minutes or so, and be prepared for not too long after that with some questions. All right, we will see you guys on the other side. All right, so we're going to talk a little bit about total area of sprinkler work and total building area. And so on a 13D project, what we would be talking about, why there could be a difference, but not necessarily a difference. We're going to have, like a 13D system as a house. When you're measuring the square footage of a house, you typically are measuring the living area, and if you would include the garage. But if we were doing a sprinkler system design in California, we would likely include the garage. And so there would be a difference between those two numbers. And so that's why we may have two. But in this situation, we designed this house as if it was in Oregon. There's no sprinklers in the garage, so we'll just have one number. And so one thing it's important to know, in the past, we have already learned about measuring these bathrooms and these closets. And we used the area tool. We could just type in area, except by, there we go, area. And then we can just go around the room from corner to corner and then hit enter. And down here in the command line, it tells us the square footage. Now, that's great, and we could use that, but I like to have a record that I did this and that I recorded it. And so the way we use a little bit different tool to measure it. One thing also I mentioned, when we measuring the area of the house, we measure to the outside face of framing. And that's typical from measuring the area of a building. So we're going to use what's called a polyline. We're going to draw a polyline in the mCAD reference layer. And there's several ways that we could get to polyline. If we go up here to draw, on the drop down, there's line and then polyline. Over here, in my draw toolbar, my classic series buttons, the second one down, it starts with line at the top, and then the second one is polyline. Down in the command line, we could type out polyline, but there's also kind of a quick way to do it just by typing PL line. But if you just type PL in IntelliCAD, polyline will pop up. And so I'm going to click on that. And now I'm going to zoom in, and I'm going to go outside face of framing away from the building. Or outside face of framing on the outside of it. I'm going to go in a clockwise order around the building. Now, I don't want to include the garage. So right here, I want to imagine a point that is directly across from here, right about there. And so I'm going to go up here to the perpendicular snap. And then you'll notice when I touch this line with my cursor, that perpendicular symbol pops up to the right where I want to be. And when I click, that's the point that it snaps to. You could see it there if I turn off my snap more easily. I mean, my, let's see, F8, whatever that is. I'm drawing a blank right now. Ortho, there it is. So now I'm going to carry on outside face of framing. And I'm just going to follow it along the building. And when I get to my final corner where I started, rather than clicking there and connecting it, if I go down to my command line, there are some different options here that I could type. And one of them is C for close. So I'm just going to go ahead and do that. Hit C, enter. And that completed the loop. Let me zoom out. Excuse me. If I select that polyline, you can kind of see that it's going around the building. Use the move command, and I'll just put it up here. Now, if we select that polyline, we go over here to properties. I'll zoom in a little bit again. We come down here into the geometry area, and it has here in the area first in inches and then square feet, and so it's got 1,437.8953. So we're going to put 1438. We're going to round that up. So one thing that I like to do is I'm going to hit escape. I like to just grab a piece of text It doesn't really matter what it is, and stick it in there. And then just change it to whatever that number is. And then I kind of, if I come into this file and look at it, I have a visual record that, oh yeah, I measured the square footage of this building, and that's 1438, and that should match the number if we go to our paper space and we zoom into, let's try to think here for a minute. Zoom in to this area above our head legend and our floor plan, fire sprinkler layout, title bar here. I already typed it in on this one, but there may be a question mark on yours. You can double click on that text and change that to 1438. All right, guys, that's. Sorry about that. I cut it short by a few seconds. Hit the wrong button. Apologies. All right, let's go. Next thing. All architectural base CAD layers set to color 252. And that is all about making the architectural background drawings that lighter gray so that our piping and our text, everything just, pops and is easy to read and follow on top of that. And in this next item, all text on plans meet mCAD standards. And so all of the items, most of these boxes are already 90% filled out, and you're just double checking what they say, making sure that it's correct for the project you're working on. And we have you can see there's two text sizes right here. If you were to print out a drawing and measure it with, a ruler, one of those is 1/8 inch high and one of those is 1/4 inch high. That's all by design, and that's basically the two main texts that are used and are acceptable, in our mCAD standard. It's Arial font. There are a couple of exceptions in our system, but the point is that in general, we have a standard even for those exceptions. There's only specific places where they are used, and there's reasons for them. So like we have with the dimension style, the the text on the title block with the address, you can see all of those are the same size text. Even the dimensions from the drawing are the same as the text on the rest of your drawing, and it matches, same font, everything. All right, so mCAD and sprinkler contractor logos loaded and in color. This is just to double check that these are basically image files that are loaded into the drawing. Sometimes the path is going to get disturbed, and you have to retell it, relink it. And so before we send these in, we just want to make sure that they look good. And all mCAD layers set to color 7. It's a little bit odd. Color 7 is white/black. We do that just when we plot. And we have, you should be able to see your mCAD layers should stand out if all of your architectural layers are set correctly to the 252. You can see all those on the outside of the colorful layers in the center, which are the mCAD layers. They all say mCAD at the beginning, so that's real easy. You can just click on layer name at the top to sort them by name to get them all grouped together like this. And then it's just real easy to select them all, change them to white, which is white in paper space, or white in model space, and black in paper space. That may be confusing for some of you who are new to the CAD world. That is kind of an oddity. But so this is what it ends up with. Again, we've got this nice light architectural background, very crisp piping, easy to read all the text, even if it somehow slightly conflicts with the architectural background. It's still very easy to read over it. because of the contrast. All right, and then we just have we we didn't give you what we have for additional jurisdictional requirements, but we just showed a space to allow you guys to put where you're at. What do they require? There's all sorts. It's really just wide range. I think earlier tonight I mentioned one of our local jurisdictions that has special requirements for that tenting detail. Just has to have specific verbiage, and they'll kick it back every time without that. Everybody's just got a slightly different take on the code book and how they want this stuff interpreted, and we just try and collect the information when we work with new places, and so we remember for next time, and just do our best to just give it to them, if it's not that much trouble. So this is basically after you guys complete what we demonstrated with the cross section in our video tonight, and let's see what else that was. Our completed project. This is it. Congratulations, guys. So this week, this is it. Finalize your plans. There's another look. This is what they should be looking like. If they're not even looking close to this, or I don't know, just you're struggling for whatever reason. Maybe you can see it to some degree on the CAD screen, but you can't make it compute to the PDF. Those are steps that can be struggles for people. Just let us know. Let us help you. So we want you to be successful. We want to help you to be able to finalize your plans this week so you can be ready to submit your plans to the authority having jurisdiction, which is us in this case, of course. So next week, we are going to go into course wrap up. Where do I go from here? Well, we have some stuff in the works. We have some friends who have stuff in the works, and we want to tell you about all those things. We want to talk about the potential with CAD. And we think it's, there's a lot, not just with fire sprinklers, but we think that there is a lot of potential in fire sprinklers. It's a high demand industry with, not many people that know about it. So we're going to talk about things like that next week. Also, again, this Saturday, Chris Jansen and I will try and be there too. I'm usually at least in the background. He started last week, custom desk design, and he will be continuing this next week on that project. So again, SketchUp, super fun if you haven't played with it. Super easy to work with. Thank you for being here tonight. And like I said, we are just going to go straight into Q&A. All I have to do is figure out how to stop my share screen. So if you guys have questions, this is the time. Hopefully, if everybody can. Monica, does everybody have the power to unmute as well? It's like Hannah just dropped in. Sorry, Hannah, you missed all the good stuff. We just started Q&A. But it doesn't matter if we got questions. Let's bring them. How's everybody doing tonight?
Colby,
Yeah, hey
I had
Michael.
I was just thinking, obviously, fire sprinkler systems are designed to protect against fires that begin within the home or the structure. But what about these California fires that are begun by nefarious actors or whatever? Is there any talk about beginning to make, in certain places at least, some sort of external systems?
Well, they exist. What are those exposure systems? That's what we call them. I've designed systems out here in Central Oregon for what's the name of that museum? South side of Bend. Anyway, they have this Oh yeah, the High Desert Museum. They have all of several displays that are in the trees, and all the buildings there have exposure systems. And we did one of the additions one year there, the company I was working at, and so I designed the exposure system for that. They exist. It's very difficult to provide exposure protection on a house to have basically to be able to come up with enough water. It takes a lot of water to protect at that level. It does seem like there should be something that some sort of happy compromise should be able to come up to try and at least do something. um, but it basically takes a lot of water to run those, and there's like the 13D system. One of the things we talked about is we're only providing enough water to, for the people to escape, not necessarily to protect the structure, and that's to keep the price down, the costing down. And so really, to store the amount of water that it would take, it's just kind of unrealistic on many fronts, unfortunately. I would say that there's a combination of things that you can do. I've seen some homes that were interesting, and some of the been going around Facebook groups and stuff. There was like kind of a modern looking home that had there's a couple good reasons people were talking about why it did survive. It had it was like a very modern looking house and didn't have like eaves to catch flames and whatnot. And then also it had like a hardy siding, cement board siding. And I really think a combination of these things is the best approach. I mean, I would be all for putting an exposure system on. It's just like if you think about this sprinkler system, we're just to do two sprinklers to operate inside for 10 minutes, we need a 350 gallon tank. So, how many sprinklers do you think it would take to cover the perimeter of your house? And how long would we like those to operate? Theoretically, through the entire fire event, I would think. Because if it just ran for the 10 minutes, that fire is going to be hot enough to just kind of make that water evaporate and not do that much good. So it's really a tough situation. I really think you're better off looking at, making sure you have clearances from other possible fire things, close to your house, those types of things, keeping clear distance, bigger trees and stuff cleared from your house. And the hardy siding, cement board siding is really, I think, a big thing that saved that. But also, it makes a lot of sense to me that because it had no eaves, most of these places, it's a great place to catch fire underneath the eave, and then they just go up and with the flammable siding. But
In Oregon, what happens with the regulations if a house is made, say, of masonry block? If the structure of the whole house doesn't involve wood, does that change the requirements for the sprinkler systems?
well, what kind of masonry block are we talking about? Not really, I would say. But what kind of masonry block are you thinking?
I was just thinking about, concrete masonry units or something like that that didn't have a wood framing structure underneath it. If that
Yeah,
changes it.
like unreinforced CMU blocks.
Mm,
Yeah, we don't. It's really not legal to build much of anything in Oregon with that anymore because of
okay,
seismic.
right. Because we don't
Uh,
have that down here on the Gulf Coast. We don't have a lot of seismic regulations, so I can understand that. But I'm sorry
I've
I cut you off.
Oh no, no, not at all, not at all. This is great. I used to work with a structural engineer, a buddy of mine, and we did a few retrofits in Portland seismic upgrades, and it's pretty much a nightmare. You pretty much just got to build a portal frame around the thing. It's pretty much just going to crumble.
Mhm.
You know, like just build a big steel frame around it to hold the thing up. Like it's they just crumble.
Well, in any case, so if you have, say, steel framing instead of wood, are there any other separate codes that are pertinent to structures that don't are just less flammable?
Well, not that I'm aware of as far as 13D is concerned. You know, like if you're in 13, the type of construction definitely affects the sprinkler coverage that you have. Like if it's a, you know, like a non-flammable construction, like you're talking about, like a red iron building, say, and it has an office space in it, and the space above that, you know, is non-combustible steel. It doesn't need sprinkler coverage up there. But if it's a wood frame building, like type 5 construction, then it would have to have, you know, sprinklers above a drop ceiling, because that's a combustible void. So it comes into play more in 13, I would say. I'm not aware of you being able, like if there's a place that requires you to have a 13D for system, I'm not aware of any way you can get out of it by having a like fireproof house of some sort. With 13D anyway, you know. But you know, great question.
Yeah, if a 13D system activates, everybody gets out and it burns to the ground, that system was 100% successful.
Right.
That's the idea behind 13, correct?
Right. 13D versus 13. Yeah. Both 13D and 13R are really just to give people time to get out. 13D to give people 10 minutes to get out. 13R to give people half an hour to get out. That's why you have to have a half an hour water storage, you know, if you don't have a water supply, and you have to have a big tank for half hour. Whereas 13, you are actually protecting the structure and the commodity within it. That's why 13 is much more complicated.
I can tell you every fire I've seen in a residential property that has fire sprinklers, it's put the fire out. It works great.
That's very good to hear. Oh, and I'm curious, all the ones that I've seen were put out by one sprinkler. Have you ever seen one with a second sprinkler go off?
No, I haven't. It's always been one, and it's the one right over where the fire starts.
Yeah, I think that's really interesting. They really do work well, and the second head that we designed for is really just a redundancy. Every single one has always just worked with one head. It puts the fire out. And it's so much, people are really concerned about, you know, water damage from the sprinkler system, but that really comes from a lot of misconceptions. Like the sprinkler, yes, it's going to be dumping out water immediately right there. But think of you, if you had, you know, as long as you're there to shut it off immediately, you know, it's done. You know, as soon as the fire's out, it can be shut off. No big deal. If it's hooked up to a tank, it's going to run for 10 minutes. It'll put the fire out and nobody's there. It'll just be done after 10 minutes. It dumps 350 gallons of water. And yes, that's not great. But imagine if there hadn't been that sprinkler there and that the fire was allowed to go till maybe a fire department showed up 10 minutes later. How much larger do you think the fire would be if they even show up 10 minutes later? And how much damage do you think that fire hose that's spraying 250 gallons a minute, that's basically like a giant cannon, you know, just, you know, hosing down your house? I mean, how much more, you know, do you think there'd be it's slightly more damage, you know, clearly. Anyway, it's interesting. People really think, a lot of people think that like all of the sprinklers in their house will go off at once or something like that, you know, but they're individually activated. You know, I could see people being concerned if it does go off and you're connected to a municipal system and, you know, you are gone and, you know, just going off for hours. That would not be good, right? But there's stuff that you can do to mitigate, you know, having the system monitored and whatnot if you're not going to be there. It's a problem here in Central Oregon with the freezing. there's a lot of vacation homes out here that have sprinklers in them. And they freeze and break, and they end up converting them to antifreeze systems. They put glycol in them, and the systems really don't work as well. And they're supposed to be designed slightly with a slightly different hydraulics with the glycol in it. And so it's really not quite right, but there's nobody in the house. They allow them to do this here. Anyway, it's just kind of a strange problem because we have, freezing weather with these homes with nobody in them for large amounts of time.
Is that a non-toxic glycol that they use?
That's a whole thing, right? I seriously doubt it. Like, there just recently switched to, like, there was this I'm sure it wasn't before. We used to just go and buy this like 50-gallon drum of glycol, and I don't know, it was toxic waste or whatever. I'm sure it was awful. Now there was a thing that changed a while ago where all of a sudden you had to have listed glycol. Well, that was a problem because there was only one manufacturer for quite a while. It's Tyco. You guys may have heard of Tyco. Well, so it was, real expensive, and it was basically the only one that was legal for a period of time. But anyway, it's real expensive. I seriously doubt that it's not toxic.
Well, I don't remember all the different types, but for antifreeze in a car, the standard stuff is I don't remember if it's propylene glycol or whatever, but it's it will kill. I mean, it's just I think something like a tablespoon of it or a teaspoon of it will kill a pet. And of course,
Gotcha.
wives know about how much they have to put in their husband's coffee to get rid of them. So I don't know how much of that you want dumping all over your house, and your pets might be
Right?
licking it off the floor or something. Sounds kind of nasty.
That's funny. Yeah. Yeah, no doubt. No doubt. Yeah. And man, it's real. So somebody, like, there's a problem, like, with this stuff is so expensive. I think a job in Portland, somebody called to ask me about. It's a giant parking structure. Not giant, but it has the biggest antifreeze system I've ever heard about. And they were wanting to convert it to a dry system because the glycol in it was old. It needed to be replaced. And the cost to replace the amount of glycol in this system was like, just for the glycol itself, I think was like $35,000 in this one system. Just like insane. Anyway, so they wanted to look into converting it to a dry pipe system, but they would have to completely replace the entire system, which would have been like probably a couple $100,000 at least. And so they just went with replacing the glycol again.
Do you also design dry systems?
Oh yeah.
Okay.
Yep. All kinds of stuff. Yep. Just about anything you can think of. I've, in my career, over 25 years in sprinklers design, done all kinds of buildings. It's just basically up here in Oregon, we have, it freezes here. So any unheated area that requires sprinklers, you're either going to have a dry pipe system or an antifreeze system, which antifreeze is more rare than dry pipe systems up here, but they're out there. And then also we can use what are called dry barrel sprinklers that the barrel of them is dry, but you can connect it to a wet sprinkler. So like you can have a wet system inside a heated space and then pop them out the wall to an unheated space to cover it like that. This is a short one right here. Like you would just put this out the wall into the hood. This one happens to be a pendant, so it's supposed to be in this position, but sidewall ones would be the same thing. You just pop this out the wall, and this is an heated area, and out here it's freezing. And, depending on how freezing out here it is, or how, like, the part of the state you're in, it's one side of the mountains it gets colder than on the other side. And so the average, yearly temperature drops lower. And so you have to actually have the barrels longer on the ones over here on this side of the mountain. And it actually kind of causes a problem because it gets so cold, you have to like have them way back into the heated space to make sure that they don't freeze. But it ends up being like 1.5 feet in the wall, into the unit sometimes. And so you'll see these apartments over here that have this weird like box, just thing sticking out of the wall, is like in a weird part of the room, and people don't understand why it's there. And what it is just they were just trying to cover up this thing that is required by code that nobody knows what to do with. It ends up being like 2 feet long, and it sticks into the room a foot. And so they try and box around it so people don't bang their head on it or whatever.
Now, in a garage type situation in which you might have chemicals or gasoline or oils, or do you need to adjust for that scenario?
Not really. I mean, so it's kind of like in Oregon, there's almost no place that makes us sprinkler garages. California, they do. Like I just did one the other day in Colorado, and it was a residential sprinkler that we used. They did use steel pipe. It's like a preference thing though. Like the CPVC is allowed to be used. Like they ran the pipe around the garage exposed with sidewalls spraying out into the center of the garage, but they use steel pipe, and just because it's like just more robust looking. Like it's legal to do the plastic, but it just kind of looks chintzy. And if somebody jumped up and grabbed it, that you could break it fairly easy. So like that's how they did it. They just ran steel pipe in there just for the reason to make it be more robust. Because it's in like a work environment, like a garage. Like you're saying.
Yeah,
But they're
but I
really.
guess
Oh, go ahead, Owen. Yeah,
I
you
was
might
going to
have some
say,
insight.
you have jurisdictions that require heads in the garage. There's usually 4 heads. So they require you to have the system riser off the garage and have you flow the 4 heads. Have you run into that?
No, is that something you have? Is that like one of those what is it? Modified 13Ds they have in LA
Yeah,
County?
I can't think of where that's required right now, but it seems silly to have heads in the garage when they're not going to really do much with regard to fire load, except and most people don't exit out through their garage anyway. So it's just makes fire officials feel better, I guess.
Right. One of the things that one I was talking about in Colorado that was interesting. This is the first time I've ever ran across this. That jurisdiction there, if you use a tank and pump, they want you to do a 3-head calc. So they have to, that makes you end up having to have quite a bit bigger tank. I think we needed like a little over 500 gallons of storage to make it work. So,
is there a calculation to figure out replacement from domestic water as it's flowing to meet that amount of water?
Yeah, sure. Yeah, I've definitely done that in situations. All you got to do, you need a 10-minute supply. So say you have a 350 gallon tank. Well, like this actually happens a lot. I can't remember which head this works out with, but if we calc 2 heads, we end up needing 360 gallons. And so that's only a 10 minutes, 10 gallons. You only need to make up a gallon a minute. So all you have to have is evidence that the domestic supply can produce at least 1 gallon a minute, which is pretty easy, right? Well, usually, hopefully, it's a number that's just easily provable. But it usually doesn't take much. You can, because you usually have a tank that's just really close and you just need a little bit more.
Well, I guess one of the things that go ahead, Owen. Sorry.
Well, I'm just finishing the thought. Having to do forehead counts occasionally in these large homes, but let's say we need to use a tank. Would the domestic refill be enough for foreheads flowing?
Well, I think, let's see, I would say if you did like, let's say you did a 12 by 12 spacing head, that would be 9 GPM. So what's 9 times 4? That's 36. Actually, maybe that's the situation. So that's 360 gallons right there. So the 350 gallon tank, you would need 10 more gallons. And so that would be 1 gallon a minute that would need to be supplied by the domestic system at a refill rate.
Okay, I get it now, the calculation. Good.
So
Go ahead,
that would
Michael.
be doable.
Yeah, I was just going to say, because I haven't really thought about sprinkler systems that much. And I'm just thinking aloud kind of, but I guess these systems are designed for people not being there. So if you're talking about, let's say, handheld fire extinguishers, you've got to think about the fuel for the fire, and you don't want to put water on certain things like oil fires or whatever. But in the case of sprinkler systems, you're not supposed to be there anyway, so it doesn't really matter. You just drop water on whatever it is and just try to cool the situation and douse whatever you can.
Right. I mean, theoretically, there shouldn't be a spontaneously creating itself grease fire in your house with no one there, but I guess. But yeah, totally. That's it. Just
Well,
dump water.
we had some renovation in the city of Mobile, Alabama, where I live. There was I don't know, a building that's probably, let's see, could be as old as 200 years old, and it was being restored, and somebody threw some rags, in a trash can or something, and they spontaneously combusted. And then also, I
Gotcha.
wonder what happened. I used to live in Copenhagen, Denmark, and I noticed it was earlier this year or last year, the Bourse there, the stock exchange, was being uh, restored, and it was the most famous, kind of like the Notre Dame of Copenhagen, and it burned just like, as did Notre Dame. So maybe that was spontaneous combustion events from these kind of different chemicals mixing or whatever.
Gotcha. Yeah. Well, so like really, like there is stuff in 13 that allows, like, is thinking about that stuff when you're storing commodities, like those that would have very specific ways of storing things that are combustible in nature. But everything about 13D is basically about keeping the costs down. And so
Mhm.
it's really doesn't have any of that, like anything about what's in it. It's really like only 13 is concerned about the commodities inside the building, basically.
So for a grain elevator, they would use 13.
Yeah, absolutely. Yeah, like
Oh,
big. Go ahead.
I'm just going to say, if you think about it, the commercial heads, they spray down in a conical fashion to hit whatever's burning. Like with a residential head, it's very flat, goes across the ceiling, and it's not, what is it, 18 inches down on the wall? Kobe is the maximum expected.
Yeah, it's like like a foot to 18 inches. It's really tight. Like it really sprays out flat and hits the corners of the walls
And that's to
almost.
prevent flashover. That's what kills people suddenly is a flashover. You get heat, and that's why it doesn't, not supposed to put the fire up, but they essentially do. That's the difference between a residential head and a commercial head is the way they're designed to control heat. Residential and the commercial is to put the fire out.
Very cool. Thank you, Owen. It's excellent.
I was just going to add, talking earlier about the fire department response, I have definitely seen situations in which the fire department creates more damage to the household than the fire did. And in a lot of cases, they basically say, they're just making sure that, there's no embers. And so they spray the hell out of everything. and chop the hell out of everything to make sure that there's no residual fire anywhere or whatever, but end up doing a hell of a lot more damage. And that might be a selling point in regard to like your insurance, as well as, just the homeowner, not wanting to have that kind of damage.
No doubt. Yeah, no doubt. I've heard some horror stories as well. I'm sure that Owen never was responsible for any of these typical firefighter stories that we hear about this machismo guys that have to run off some adrenaline. But
Yeah, that's true. In training, we're now taught do what's called penciling, where you go into a room which is very hot and you actually shoot the hose stream up towards the center of the room, but pencil it, on off to cool the atmosphere down. You get 1,700 times the volume from water to steam, and that puts the fire out. Where we've had guys, and it's usually the new guy, goes in and he's slinging 250 gallons of water a minute all throughout the room, knocking over grandma's ashes on the mantle and everything else that's in the path of the fire hose. But we do try to minimize damage. We do realize that, but it happens.
yeah, and I'm sure it's like it's worse in other areas than different cultures of firefighters in different places can really vary a lot. It's pretty interesting.
The other thing I wanted to ask is, the changes in the fire code because of things like, electric vehicles and stuff like that. Because, like talking about sprinklers in the garage, many of these Teslas are going up in flames in the garage, and many people don't even suggest you put the car in the garage because it's such a potential fire hazard.
Yeah, I'm really curious, Owen, if you have any thoughts on that. Being in Southern California, there's quite a bit of electric cars. I mean, my understanding, I know that there's been a lot, like NFPA has been writing a new book on protecting lithium, but I don't really, my understanding is there's not a lot you can really do. And even in these, like these houses, like we were talking about, like I wouldn't park my electric car inside my house that I was sleeping in at night. How do you feel about that?
Well, I retired almost 13 years ago, and that was before really electric cars were popular. So I have no experience with electrical car fires.
Okay. Well, I know that they're literally been working hard on writing a new book to try and figure out how to deal with it. But and even from the car accidents with these cars, a lot of times there's such a bad flashover that there's like not even time to think about getting out of the car after an accident. And the magnitude, I don't know if you go ahead.
Well, I was just going to ask if most of these happen because of some sort of a, like, as you say, a wreck, or can they just spontaneously overheat and ignite for some reason?
Well, I mean, I don't know if I have these little drones that have lithium batteries, and when you take them out, you put them in this bag that's a fireproof bag, so they don't just spontaneously combust in your closet or whatever and catch your house on fire. I don't know. It's like, it's a thing, these are supposed to be like higher quality lithium batteries in these cars and stuff, but it still seems like definitely on impacts where there's some sort of damage like that, sudden impact, it definitely starts combustion. But it seems like I've seen some pretty crazy stuff. Just anything that sparks it, it's just once it's sparked, that lithium just goes up. Like it's just a flashover thing. Like there's just like nothing that can be done. It's just like instantly, it's just like the thing's up in flames. And definitely no
How
13
long
D
did they
sprinkler
burn it?
system. Well, I mean, car fires. If even just a regular car, if you've ever had the opportunity to see that, Owen, you probably got to practice on quite a few of those, I imagine. Uh, I've been like riding my bike. I'm an avid cyclist and riding my bike on the side of the road and happened to come up on like a car that was like bursting into flames. And the whole thing was like, man, it was just completely gone. And like, you couldn't believe how fast it was. I don't know what's typical, Owen, what you guys see, but it just seems like even just a regular car besides an electric, the whole car can be a complete loss in just a few minutes, really.
Yeah, if it's a fuel leak, you got a problem. And that's usually why most car fires start, is a fuel leak. Then you're chasing it.
That makes sense.
I'd just say in the shipping world, there's been, I don't know, 7 or 8 ships that have basically either burnt or sunk because of electric cars being transported
Oh,
into the
really?
fire and
Wow.
starting out a number of cars on fire. And then like once one gets on fire, then another gets on fire, then you got, 200 or 300 of them. It's over with.
Yeah, no doubt. Yeah, especially all contained in that close quarters. I would imagine.
You got to
There
run,
is
guys.
there is
Oh,
some
thanks, Owen.
Good
spontaneous
session.
danger.
I'll see you next time.
All right, have a good night, Owen. Thank you
All
very
right,
much.
talk to you later.
Yeah.
I'm guessing that the crew doesn't have time to get off the ship in such a situation many times.
Oh, yeah. I hadn't heard about that. It was a total loss? They all die, Michael?
Well, I think there was a couple that happened in Europe where the ship was just off the coast, like they just left the dock or whatever, and the things burst into flames. The crew evacuated, and I think maybe one of them got hurt,
Hmm.
trying to fight the fire or whatever. But then it was, they were wondering if it wasn't going to, because they had like fire boats spraying water on it, and they put so much water in the ship that it was listing, and they were thinking it was going to go down. But then they ended up uh rescuing it or whatever, and then they pulled it back into the thing, and they were pulling the cars off, and the car, like each of the cars, they had like a big like dumpster full of water, like big enough that you could just set the car inside of it. So like they were taking the cars out of the thing, and they were examining them with the like a heat gun or a heat camera or whatever, and they were dunking cars in the water and just leaving them there because they apparently were going to potentially go up again.
Yeah, that doesn't surprise me. I hadn't heard about that specifically. That's interesting.
But a lot of these cars that are like in damaged areas where like the hurricanes happen and stuff like that, and the water floods and the car batteries get water and stuff like that.
Mm.
Many of these are, potential short type situations. And that's one of the things about, uh, that whole kind of insurance system is you basically have got, like, if the car was ever immersed in water of, I don't know, 12 inches or something like that, essentially that car has got to be totaled, and it can't go, it's got to be destroyed. It can't be shipped off to, South America or something.
Right.
But we've got one of our autonomy people is a bicycle mechanic in New York City, and the electric bike situation in New York City is one in which they're having a ton of fires created by Chinese batteries in, apartments where, they're basically like bicycles. So they're putting them in their staircases or whatever. And these bicycles are catching on fire and, taking an apartment block out.
Yeah. I had heard probably 6 months ago about some people being upset about their apartments have a posting about, no e-bikes in the building, and because of the insurance provider wouldn't allow it. And like, I guess there's only like 3 insurance companies in the world that insure apartment buildings, and one of those 3 said that they would not insure apartment buildings anymore if there were e-bikes in the building because it's too big of a fire risk. I didn't mean to cut you off there, Michael.
No, it's
Well, I was just going to say that, all this is good for the fire sprinkler business, I guess. I haven't followed the California fires very closely, but I just looked some today, and y'all probably already know this, but apparently a lot of the insurance contracts were canceled very recently for fire. And that I can't help but think that this big fire event on Los Angeles is going to change a bunch of industry standards some way or another. I mean, I'm not going to try to predict how, but I would think some legislation is going to come out of this for sure.
Yeah, it's going to be interesting. I don't know. It's hard to say. It's already a major demand in California for fire sprinklers because all residences have to have fire sprinklers already in California. And there's already like a like a bigger demand than there is people for or whatever. And now there's going to be a lot more needed. Who knows how many of the houses will be replaced with actual houses versus something else. It's going to be interesting to see what happens.
There'll probably be a migration. There'll probably be people who never come back, I would imagine.
Right. I would imagine. Yeah. So,
billionaires win again.
I will be trying to take advantage of the opportunities that we can avail ourselves with regarding that, but it'll be interesting to see how it plays out.
Just another little thought about external systems. If if one is concerned about a forest fire coming to his house, that's a different. You wouldn't necessarily need the gallons per minute, I wouldn't think, as you would if you have an interior fire where you're trying to immediately put it out. But could you not have more of a trickle against an exterior concern? You're just trying to sort of keep the house damp and don't need the flow rate potentially.
Yeah, I think that would be. I absolutely think that in fact, a friend of mine. I can't remember who it was exactly. It doesn't matter. I remember we talked about a scenario not a while back, similar situation. And I was really thinking, you're probably right. Like, especially what I feel is if you combined it with the other things we were talking about earlier, making sure you have as much as you can cleaned up, brush away from your place. Not having eaves is not the look that everybody wants, but that can see how that massively is a help. But anybody can do the concrete board siding. It's more expensive, but it's a good product.
Well, there's a man named Joe Steberick who talks about, he's, I believe, Canadian, but he's developed something he calls the 500-year wall, and he puts the insulation on the outside. And that guy from Texas who does a lot of building shows, his show is called The Bill Show. His name is Matt Reisinger. He
Okay.
has talked about going to exterior insulation, and I've heard that a lot of, in commercial applications, it's already kind of going that way. But to put the insulation on the outside makes it easy to do a house without eaves because you're just wrapping the entire outside of the structure with the insulation. So that may be a coming trend just on the basis of energy efficiency anyway. But to the question, a lot of times, and I don't mean to be all cynical, but you know, Colby, this could be how you make your millions is you design a system that trickles to the outside of the house and sell it to Southern Californians and tell them it'll protect their houses against forest fires, even if it won't.
Well, I mean, I think that's the spot where you get into trouble. I think it definitely would do something. I would even be fun to experiment with and try it out. I can't. I would think, especially if you had all of those things in concert together, you know, with the whole thing being drizzled, drenched, you know, with a mist of water, you know, like a soaker hose type of thing, just keeping it soaked. That, like, it seems like that has to have some effect. You know, I don't see how it couldn't. But it would be interesting to test it and find out. You know.
I saw some headline today. I didn't read the article, but it talked about aircraft, I guess helicopters picking up ocean water and dropping that, and it says something about the problem of dropping salt water, and you know you can imagine what that could do to the soil or whatever. But you know, California being as dry as it is, I guess the desalination is a big process that can't be done very rapidly. Could they have pumping systems that pump ocean water to, you know, I mean, Malibu or, you know, in Santa Monica, I think we're burning up and they're very close to the water. But I don't know enough about desalination to see how to know, because we heard that there were maybe, and everybody blames Gavin Newsom, and that's probably fair enough to do, but that he had not allowed enough of the water systems to be replenished, or had kept the water levels low, so the fire hydrants were running out of water or something. But anyway, I'm just kind of thinking about how when you've got an entire Pacific Ocean nearby, what can you do with that water that won't create some sort of a Carthaginian uh, soil condition after the fact?
Yeah, you know, man, the thing I mainly, you know, what I see was what people were posting stuff about this on Facebook and different places. It always seems like the most interesting information you find in the comments. And as I was looking at some of these things that were being shared in various places, um, you know, it's hard to know what's real, but it seems like people who seem like they were knowledgeable of, you know, waterworks systems and, you know, how, you know, just things that would have happened. They appear to have like this kind of amazing system that could have provided all the water they needed in a matter of minutes and were not allowed to use it. Is my understanding. And, you know, don't quote me on that. But
There was a major reservoir in that area that was basically empty. It had been sitting empty for a few years, and supposedly they said they were going to do some maintenance on it, but the maintenance never happened. And so that
right.
billion gallons of water that they basically could have had access to was not there.
Well, and it sounds like they have other systems in addition to those that I haven't really been hearing people talk about in the mainstream. I wish I should have like screenshot it, but it sounds like there's other systems that are in existence that were ready to go and just needed to be turned on and were not allowed to be done so. But I don't, you know, I don't know. I'm not.
There is a YouTuber that's I think his channel is What the Ship. He's a mariner, and he's a professor at one of the mariner colleges. but he's also a firefighter. He just did a video on using salt water, and essentially, yeah, you can use salt water without any problems. Uh, there is a kind of some myths about what you got to do when it comes to like maintaining the equipment and stuff like that, because you do have to flush everything with fresh water eventually. But yeah, it's certainly possible that they can use ocean water to put out fires.
I remember hearing back during the George Floyd burnings that went on, however many years ago that was. Catherine Austin Fitts of the Solari Report said she had her staff research where all the fires were and in proximity to Federal Reserve branches, and something like 22 out of 24 of the fires were within blocks of a Federal Reserve branch. And she said, okay, well, that's a pattern. And she was conjecturing that maybe they were burning these areas to devalue them so they could put their smart cities, devalue the land so they could snap it up and put their smart cities in those areas. And then I have seen some conjecture on the internet about that surrounding the Los Angeles fires, that maybe there's some intention. Of course, you're always going to hear whatever. You never know what the reality is. But if it seems like a lot of things that could have been done were not done, we've seen that before.
Yeah, unfortunately, it's I guess I just always try to assume the best and do do the best we can with the information that we have. We're going to be able to profit from this sad situation, unfortunately, that was created possibly for nefarious reasons. We don't know. I mean,
Well, I
maybe.
think we were talking about this earlier today about because we got one of the autonomy people are in Los Angeles, and he was saying that the wind speed was incredible, like over
Right.
100 miles an hour, and the like the fire bombing during World War II and subsequent situations, but in particular like Dresden, they created a situation in which the heat of the fire actually created a firestorm where it became like a you know a fire tornado. And it would be interesting to examine where all the fires were and then how that related to the winds, because the wind could have been driven by the fires. Because if you got enough air going up, you got to suck the air in from outside, and essentially you create a firestorm.
And I know that a lot of the, 20 years ago, we were always told that it was a crazy wackadoo conspiracy theory that there was any such thing as cloud seeding, or that there were chemtrails and all this, and it's all openly admitted now. And oh yeah, that was always true. But so who knows what kinds of conditions? I remember however many years ago it was, 2 or 3 years ago, when they had that crazy winter storm that came through Texas, that everybody said this is, well, I saw a video of people balling up snowballs and trying to set them on fire with a lighter, and the snow was burning, turning charred instead of melting. So, there's a lot of weird stuff that goes on.
Yeah, I saw like one of the Facebook groups that I'm in is like, Volkswagen Northwest thing, just people posting classic Volkswagens and stuff. And somebody posted a picture of an area that was completely burnt, everything just singed to the ground. But for whatever reason, there was this, it was a like bright blue, I think, Volkswagen bus that was like untouched. It was really weird. Uh, anyway, like that they took, anyway, they're just sharing it that the Volkswagen survived. It was like, happy victory or whatever. But how is everything everything everywhere just like totally burned to the ground, but this one thing for whatever reason is just untouched. It's crazy. There's actually a guy I'm friends with on Facebook, a contractor in Southern California that he bought recently a fire pump for testing and maintenance for his business, and he's been taking it out to the front line and helping the firefighters and pumping water out of people's pools with this pump for them to be able to use that with their fire hose. So he's just a person who had that, who's volunteering and bringing it out there. They don't have any equipment like that apparently of their own. It's kind of crazy.
Well, that's a good idea for the Beverly Hills set because they've all got swimming pools. So,
Right.
some enterprising entrepreneur could go sell a bunch of pumps for them to spray their houses down with their swimming pool water.
Yeah, that is a good point. Yeah.
So
Yeah, a
there you
lot of
go.
places in California have.
Swimming pool could be your, your reservoir, fire defense reservoir.
Yeah, that is a good idea. A lot of places in California have a pool. Even, not like it's just really common. Here, nobody has a pool.
That was in the Beverly Hillbillies theme song, "Swimming Pools, Movie Stars." So I think that's there's your design right there. You just tie the external sprinkler system put a pump at the bottom of the swimming pool, and then just drizzle that over the house, and you could sell those things like hotcakes, I bet.
Yeah, that
Yeah,
is a good idea.
most swimming pools have a pump already, so you just have to
Sure.
have a
There
switch
you
or
go.
something that
Yeah.
you could have like a dry system that essentially just when you want, you just turn it on and it drizzles the water over the area.
Yeah, that is a good idea.
There's a lot of how many gallons does an average swimming pool have in it?
Quite a bit, I would think. I mean, because
A
just,
lot,
10,
a lot more
20,000
than
gallons.
three. Yeah, a lot
yeah,
more than 350.
Well,
yeah.
as a matter of fact, I filled up. I've had a pretty small pool here in Acapulco, and I had to fill it up with trucks, water trucks, and I
Mm,
believe it was 4 water trucks, which each water truck was I don't know, 10,000 liters, so it was 40,000 liters, so about 10,000 gallons, and it was a small pool.
gotcha.
Yeah, I think those tanker trucks, the gasoline trucks, commonly run about 10,000 gallons. I think so.
Yeah, I
That's
think a
probably
semi is typically like 8,000. Like a tanker truck is about 8,000 gallons.
yeah. There's a song by called "Home to Houston" by what's his name, and he says he's hauling 9,000 gallons of high test gas. I don't know if he did his homework before he wrote the lyric or not, but sounds about right.
Yeah, that's probably on the high end. He's probably pushing the limits of the weight restrictions.
Mhm.
But that's probably part of the song, man. He's an outlaw, right?
Yeah, it's called Home to Houston. It's he's over in Iraq during the war, and he says if I ever get home to Houston again, I'll never drive a truck again. I'm blanking on the guy's name, Steve Earle, but yeah, so he's getting people shooting rockets at him while he's hauling this gas because he wanted to go make more money in Iraq.
Huh, interesting.
Well, okay, Colby. So now you got your big entrepreneurial endeavor. You know anybody who knows how to design these things in real mechanical?
Man, yeah, we'll just add it to the list of things I'm doing right now. No problem.
Right.
That does definitely sounds like an interesting idea. We should definitely something to play around with.
Well, if you can't get fire insurance in California and you got a swimming pool, you got an answer for him.
Right. Yeah. At least you can
And it
do
would really
something.
be low. low tech and not very expensive.
Yeah, really. Yeah, that's a good idea. Wonder if there's any effects of dumping, the chlorine water everywhere that we have to be concerned about.
Yeah, well,
Um,
chlorine gas is actually pretty bad.
but
But
I think that once it's in, I guess chlorine in powder form can be explosive, right? But once it's all mixed in the water, I think it's. I've never heard of anybody's swimming pool catching on fire.
well, it is dissipated through the through the sun. The sun kind of deadens the chlorine over time. And yeah, and the amount of chlorine you're putting in a pool water is, minuscule in comparison to like chlorine gas in a nerve gas uh, projectile.
I wonder if, like, say you were spraying it on the roof and having it run down the house, is it gonna damage the paint?
Probably.
That's a possibility. That would
But who
definitely,
cares?
yeah.
Just have to have a big disclaimer about that.
Better than burning the house to ash.
Yeah.
I
And maybe
texted a
you could
friend of
have
mine
it.
today who
Oh, go
used
ahead.
to, well, I just texted a friend of mine today who used to live in Los Angeles, and she said one of her friends out there, his home and his music recording studio were burned to ash.
Oh,
Lost
wow.
everything.
That's too bad.
But go ahead, Colby.
Oh, I don't even. Oh, I think you were talking about. Well, I was the system with the, like, you could make it too so that it started with the fresh water that was available, and then if that ran dry, it automatically switched to the pool at that point and just did that as like a backup. Anyway, that wasn't as anywhere as important as your story.
Well, I think that in most of these cases, people have advance warning that there's a giant forest fire coming towards their neighborhood. It's just that there's nothing to do about it. Whereas if you
Right.
could provide, they would have time to, let's say, whatever 350 gallons you have in your regular system, you could switch that over to external use in
Right.
advance. And like you say, you would have a little bit of preparation time,
Right. Yeah, that's a good idea.
even remotely.
Mm-hmm. Yeah, there's all sorts of stuff we could do. It's remotely controlled isolation valves and whatnot.
And if you're using the swimming pool, if you have, say, I don't know, a wooden fence around the house or something, even that could be dampened to sort of keep the, the flames to create a slow, buffer. I don't know how long that would last, but, you know.
Yeah, I wonder if you could build a fence out of concrete board, if that would make a protective barrier, like the hardy panel.
Mhm.
Be interesting. Well, that's a great conversation. Thanks a lot, everybody. Next week, well, go ahead.
Well, I was just going to say, last week I couldn't be here because I was going to a social function, and I talked to my friend Leland there, whose family owns the sprinkler company, and he was
Oh,
saying,
cool.
and he was saying that they have some guys who are so good that they never have to cut on site, they never have to readjust on site everything because I guess they're dealing, mostly in commercial systems. And apparently not all of the CAD operators are as good as that, but he really likes the ones who don't cost him any extra money and time or materials. So I thought that was an interesting conversation. I asked him if he'd like to be on a call. I took the liberty of asking. I don't know how you feel about that, but he couldn't do it this week anyway. He travels a lot, but I thought he might have some interesting things to say about it because he's coming from the other side
Totally.
of it, having to spend the money to put them in and rely on, you know, the draftsmen and designers to keep him from having to hemorrhage too much money.
Yeah, that's awesome. That'd be super cool. That's awesome. Thank you for attempting that anyway. Very interesting. It's funny that you just happen to know that guy who is a sprinkler company. Not, you know, most people have not even heard of fire sprinklers. All right.
Okay,
Well,
so next week.
yeah. Thank you. We basically are going to be, you know, just kind of like a review and talking about where we can go from here with other learning resources related to fire sprinklers, other stuff that we have in the works for, you know, where to go from here from 13D is really just the basics. And we have a friend, Daphne Romani, who is putting on a course on architecture that we're going to be plugging. And Michael Nimitz, since you're here, I was going to ask you if you were talking about putting an outside face to ethical emergence, your course that you've been creating. I would be, I'd love to plug it for you next week if you are interested in such a thing. And
you know, I, I have some reservations about that because I feel like I have plenty
yeah,
of supply. I have plenty of demand. I'm working on building supply, but
I
maybe
kind of suspected that might be the case.
the thing in Acapulco, if
Oh,
you
okay. Yeah, you
from
got it. Whatever,
Acapulco.
anything that you want that you're interested, we'll plug it. We'd love to have.
Okay,
Yeah, no
appreciate that.
problem. Absolutely. Yeah. Anybody else here or in the program that has something they're working on too? Let me know if you have maybe a slide of info that you want me to put out for your program you're working on. We'll plug it for you next week. Trying to think if there's anything I'm forgetting, Monica. Is there anything? We cover everything. If you are, you know, get your project in, we'll review it, get you some feedback. You know, if you are stuck on anything, also anybody out there, again, reach out. We have had a few people throughout the week that have been getting help. It's been great, and you know, just let us know. We've got lots of different time slots available, so we will try and find something for your schedule. But I think if that's everything, we will call it a night. We want to thank everyone for being here, and we look forward to seeing you guys next week for our final week, the course wrap up. And yeah, that's it, guys. You all have a good evening.